scenario 4, which I think for a lot of operations, this is probably the one of most concern that everyone's really keen to try and solve. And that's a vehicle, a HV vehicle in this particular example, performing a turn into a drive or a cuddy or a passing bay, whatever, where it's occupied by something else. And in this example, we've got a pedestrian or an LV. So here we've got the HV approaching. Ideally, we should have our A1 awareness on approach. And then if the vehicle initiates the turn and starts to transition into that drive, we should get our A2 and our A3 if he still progresses. So pretty important one, and there's lots of different variations for this one, so we're going to go through those. So first up, just on the way that the vehicle approaches, that vehicle could actually perform that turn both forwards and reverse, and it's quite common for both of those to occur. Sometimes the vehicle will actually drive past the intersection and then reverse in. That's the ideal way, and then there's a set of eyeballs looking into the bay, but a lot of the times it doesn't happen. They have to perform the turn straight in. And that can be bucket forward or it can be engine forward in the case of a loader. But with a truck, it can also be tub forward in or it can be engine forward. So that needs to be considered. If there's a pedestrian in that bay and he hears a loader coming, the pedestrian won't be standing still. I'll guarantee it. If they hear a machine coming, they'll be moving around trying to get to the edge of that bay to make sure that they're not in the way of that loader if the loader makes the turn in. So we need to consider that things may be moving in that bay. And how we make sure that we still sense that fact. And I've shown a nice clean T there, but it can also be a cross intersection or just a simple sharp turn. It can occur. If you've got a plain 90-degree left turn coming up, you could have another vehicle also wanting to perform that turn in the opposite direction. And you're really blind to that vehicle from a visual point of view until you actually start initiating the turn. So that needs to be considered as well. The images in the center down the bottom, what I've tried to show here is that vehicles can already be turning prior to the turn. So on the left, we've got a left turn, a gradual left turn before performing a full left turn. So that's really important for any of the technologies that are looking at like a bending beam technology or something like that. You may already be the operator may already be sending a turning signal to the machine prior to the actual turn, just following the tunnel in general. And the opposite can occur too, which is the next image to the right, where we've got a gradual left turn before a full sharp right turn. And that's quite common, particularly on decline. So you might be driving down the decline in a corkscrew fashion, heading down the mine. And you might hear another vehicle coming up towards you. You need to do the opposite turn into a passing bay to allow that vehicle to pass you. So that's actually quite common, that particular example. We also have the fact that our turns, our cuts or our parking bays are rarely perfectly 90 degrees. Ideally, we do want to do that from a construction point of view. Particularly from a ground support point of view, a perfect 90 is a lot easier to maintain ground support on. However, sometimes certain circumstances require a more acute angle of your drive coming off your main drive. So you can have some very sharp corners. I've seen plenty of operations that have required a multi-point turn to actually traverse a full turn because of the sharp corner. They do exist. They're not as common as the other examples, but nonetheless, they're there. So we need to consider those really acute angles as part of our turn in our design process. And because we've got that acute angle, we also need to consider that when the traffic is going the opposite direction, it can actually transition to a merge rather than a stop and turn. So that also needs to be considered as part of the design process. Some additional example parameters there just to prompt people and make them think about it is the turning speed of the machine. I've spoken to a lot of operations that have got this problem sorted out quite well because their operations are quite tight and they have very limited speed in their operations, so 6 kilometres an hour, 7 kilometres an hour. But when you're running some of the bigger operations with your bigger machines, they'll probably have a crack at some of those turns at 20 or even 30 k's an hour. They'll do it in second, maybe even third gear. So it's something to consider is the turning speed, not just the way the machine turns when you turn the steering wheel, but also the speed at which they will perform the turn also needs to be considered. So like I said, very, very hot topic, this one. Lots of people are interested in this one, as well as the next one, which is the possible false trigger for the turning scenario. And in this case, we've got the same setup. We've got the LV pedestrian in the bay. We've got a HV approaching. However, in this particular instance, the HV intends to drive straight past, so that they're not going to perform the turn. So here again, we should have a A1. However, if the pedestrian on the LV is potentially too close, we could actually get an A2 or an undesirable A3 in this particular example. Now, if this was a level 9 system, theoretically, that would be a crawl or a stop command. So that machine would come to a stop because that pedestrian or that LV was there, even though there was no collision pending. And this is quite common when you've got particularly an LV. If we focus on an LV for a moment, if you've got an LV at an intersection waiting to transition that turn, they don't park well back from the intersection. They actually park quite close to the main drive because they need to use their eyeballs to look around the corner and see if there's a machine there. So they do approach quite closely and wait or check and wait before they perform the turn. So there are a lot of close interactions there, even though it's not a pending collision. Once again, we've got the different types of turns. So you may already be doing a gradual turn as you approach that cutty. So you might be turning left before the left side cutty, even though you're driving straight ahead. So you're telling your machine that you might be turning left. So if any technology that uses that input from the steering wheel needs to consider that. And the opposite can occur too. You could be doing a full left turn and the cutty could be on the right-hand side. So, you know, probably less of a problem, but still needs to be considered. Another variation of this, of driving past something, is our crib rooms. So, you know, I mentioned it previously. You've got crib rooms and workshops. You're driving straight past them. You're not intending to turn into them. They're not exactly a bay designed for a HV. But nonetheless, you've got lots of people there, and whatever the technology is using, be it a cap lamp sensor or whatever, there will be lots of sensors there telling machines that, hey, we've got people or we've got other vehicles parked here. You know, perhaps you should have an A2 or potentially even an A3, depending on how sensitive you are. So that needs to be considered. That's a real world example there, the crib room that I've drawn there. That's probably where I've got those helmets drawn. It's probably about 5 to 10 meters away from a main haul route. There's a door in between, but nonetheless, you've got lots of helmets. In fact, they stack the helmets at the doorway before that, and we have HVs driving past. So that's a real world. The other one that we wanted to capture and discuss is our safety bays. That particularly in Canada, we have a lot of Canadian operations that have these, where they've got cutties installed on their drives. Big enough for personnel to retreat into if they see HVs coming. So we need to consider how we manage those. Some operations may want that alarm. They may want an alarm to occur even though the pedestrian is inside that cutty and trying to move to a safe place. Whereas other operations may actually want it to be silenced because the person is actually safely in that bay. So it needs to be considered. It needs to be discussed with the individual operations and with the suppliers, right? Fairly straightforward, but this one in combination with the previous one, I think is one of the biggest ones the underground community is really interested in. And we've got our passing bay, slight variation on the T intersection that I've shown previously. These are deliberate passing bays typically for HV vehicles, and they're usually installed on declines or on haul roads. You don't normally see these out in the ore body. So this is where you got lots of HV traffic usually, and you don't make the entire tunnel wide enough for 2 vehicles to drive down. You make it wide enough for 1, and then you put passing bays in stages along the drive. And those passing bays are typically big enough for 1 vehicle. However, I have seen passing bays where you can jam in multiple vehicles. And I've seen a lot of examples where you'll have a HV in there and then a couple of LVs will sneak up behind and they'll jam themselves in there to allow another HV to pass. So it can get quite congested. So once again, though, this is not a collision, right? So we're not predicting a collision here. We're intending to drive straight past, but we do have the potential for false alarms to occur. And again, if we were a theoretical level 9 operation with some sort of slow crawl stop solution in place, this would halt the operation. Now, the image below in the center below with the 2 arrows, that's a real world example of a passing bay. You can see that it's barely big enough. You can hardly tell the size of the flitch and the side of that drive. But that flitch, I can tell you, is big enough for two trucks of the order of around 55 tonne. So you can fit 2 roughly 55 tonne size vehicles in that side by side. And you'll have pedestrians that could walk down there. They wouldn't be able to stretch their arms out, but they might be able to get their elbows out and touch both machines. So they're quite close, right? The 2 machines are very close to each other. One will be driving at speed, second, third gear. The other one will be parked up waiting for that vehicle to drive past so he can traverse back out into the drive. So it needs to be considered as part of the design process. They are rarer than the T intersections that I talked about, but nonetheless, they do exist. Right, the next failure mode is where we're deliberately wanting to approach another vehicle. And there's loads of examples of this one, which I'll go through, but the one we're visually going to show is a loader approaching a truck. The intent here is that the loader would have ore and they're loading the truck, right? They're filling the truck up with ore. So this is an example of a trigger or an alarm that we don't want in the industry, right? We need this particular activity to actually occur, and we don't want to generate alarms in it. So here, if we didn't have a solution for this in place, we'd have our A1 on approach, and then theoretically we'd trigger an A2, and if we got too close, we would trigger the A3. Now, if this was a level 9 operation, that loader wouldn't even be able to unload the bucket. They would be halted prior to even reaching that truck. So that's, I guess, why we're looking at it. As I said, lots of examples of this one. We've shown the LHD loading a truck. There's also an agitator transferring to shotcrete spray rigs. So the picture in the center below is a picture of, unfortunately, I couldn't get one underground, but it tells the story quite well. We've got an agitator there unloading concrete onto a spray rig, and they're spraying a portal entry there. And so we've got 2 different machines. Granted, one is sitting still, it's not moving, but nonetheless, you've got 2 mobile machines there deliberately wanting to approach each other. You've also got other examples like service vehicles that need to come down and do a service on a HV. You've got a fuel truck. A lot of operations run a fuel truck rather than having a fueling bay. So you'll have a big truck rock up at the HV, wanting to fuel it up, needs to get in close enough to actually have the hose reach. You've also got examples where a HV will need to reverse and hook up and tow another HV. Happens quite a lot. So that needs to be considered as well. Also, there's different variations of how that can occur. So we've shown a nice, loading a truck on the side, but we actually do load trucks from the rear as well, so end to end. And we do have examples where the loader will have to reverse past the truck has to move forward to get in front of the loader will then dump, and then the truck gets out of the road, and then the loader goes off and picks up another load. So there can be a bit of a ballet of movements occurring to actually do the loading, depending on the real estate that's available at the load point. So that needs to be considered, right? So don't assume that the second vehicle, the truck in this case, once it sets up, it just sits there and doesn't move. Sometimes they actually have to move as part of the activity that's going on. And then the other one that needs to be considered is a truck loading bay. So there are many operations that love these. Wherever they can get the funding to do it, they will do it because it has a significant benefit to their operation. So a truck loading bay is where you can load a truck at different grades. So the truck will physically be slightly lower than the loader. The loader will be on a higher level, only the height of the truck. But it makes a big difference to the loader because the loader doesn't have to lift its bucket up to dump the load. So it actually improves the cycle time. You go faster. So you'll see these in operations that have quite a lot of mucking activities to occur on a certain level that justifies putting the truck loading bay in. So they are quite common. They're not everywhere, but they do exist. But it's some important things to consider there. So where there is that loader and that truck arrangement, there'll be a stop log, so there's no risk of the loader driving over into the truck. And the loader's tram will be barricaded. They'll have a dedicated barricade up so no one can enter the loader's tram. That's typically what we would see in the industry. However, the truck loading bay will be usually installed on a decline. So where the person who has taken this photo is standing, they'll probably be standing on the decline itself. We tend to put truck loading bays out near the decline. That allows the truck to be loaded and then jump straight onto the decline and off they go wherever they need to deliver it. There's various reasons why we do that. Probably the main one is it allows you to have really big trucks with small loaders. If you want to send a big truck out where the loader's currently going, you've got to make all your drives really big to suit the truck. Whereas if you keep the truck on the decline, you only have to make the decline big enough. So it's a pretty big cost-saving benefit if you can pull it off. Because we're on the decline though, we have other traffic driving past. So in the image there beside the photo, I've shown an LV driving past. We still need that activity to actually occur. So one, we want the truck to be loaded safely and efficiently, and we also want other vehicles to be able to drive past in this particular circumstance without being interrupted. If that was a HV in the place of an LV, they will be probably close enough for sensors to detect, so we don't want that A2 or that A3 in that particular circumstance. But these are sort of things that need to be considered there as well.